Ew.
What's up?
I don't know if you saw.
For some reason the chat's not. I just noticed that bracket has written into the chat, but for some reason I can't click into the chat window. Give me a second. I can share it with you if you haven't already found it. But,
Yeah.
yeah.
Can't you? You're not talking.
Yeah, I'm talking. You should even be able to hear yourself. There's no latency. There's like a 1 minute latency though.
Oh.
Wait a second, why am I typing into chat? I don't have to type into chat. Mm-hmm. Hello, Bracket. How are you? Mm. Hmm. Well, because I don't know how to use Rust and I know how to use C++, and I like C++. Thank you. So right now I'm trying to figure out, right, we have this wonderful game here, right? You can have some tiles here that you can take out and put on the board. You can move around tiles on the board and you can rotate tiles. Oh, but there's a bug. So you notice so if I put a tile like next to this tile here, which we call the power source, then it lights up, right? If I connect several tiles to the power source, they all light up, which is all great. However, if I pick up a tile that's already lighting up, it just keeps lighting up. It just stays lit up. And I don't know why. No idea. And I can even like move power to places where there was none. Like I can place this here, and I can place this here, and now they're both lit up. So this doesn't work. Well, that's something. I can move this here. Alright. Alright, so the tiles on the board are being updated. Either way, the tiles that are being picked up aren't updated, and it's weird that the connections wouldn't up. Yep, so let's see. So we have this base tile class, and this base tile class has this bool which says, oh, that's not the bool. This one, it has this array of 6 connections, and each connection has a bool is on. So in the base tile we store which of the 6 sides of the tile are currently being powered. And the thing is, so when you pick up a tile, which is handled here, if you pick up a tile, you get we look up which tile we clicked on from the board, and then we clone this tile. And the thing about this tile clone here is that it just runs the constructor of the, it just runs the copy. Oh, it runs the copy constructor. Alright, okay, for some reason I thought I had written a separate constructor that like doesn't copy the connection or like the power state. But I didn't already. Well, okay, then it's simple. Just do pick up. So tiles have this pickup function which resets them. Except it doesn't. Okay, so this function also doesn't do what I thought it would. Well, let's make it do what I thought it would. On is false. I should do it. Still not working. It's really funny, right? You win this level by like connecting this piece to the power source. Usually you need 2 tiles for that, but because of the bug you can actually do it with just 1, like this. Finished level. Alright, the exit button doesn't work. Oh, of course, I can't pick up on the wrong file. I have to do it in the clone, of course. There we go. Perfect. Alrighty. Now that works. Good. Not update, but reset. Good connection. So one nice thing about this project is that set up a thing on GitHub. Yeah. where every time you commit something, it tries to compile it on the GitHub servers for Windows and Linux. And then in the commit history, you get this check mark every on each commit where it passed. And if you commit something that doesn't compile, because I don't know why you would do that, you get an X symbol like this one. Right. Here I made some changes. I probably tested it on Linux and it worked, but sometimes the Microsoft compiler is a little bit more pedantic. Let's see, what did I do here? Of course. So unfortunately, GitHub only stores the logs for like a week or so I can't even check why it didn't work. What did I do here anyway? Oh, oh, I see. I used Pi, which is not supported by Windows. Yep. Great. Lovely. The Linux build passed. You can also take a look at the output of the Windows build, but it also passed. Yeah, I know there are a lot of warnings, but all of these warnings are in a library we're using, so it's like not our problem. I declare. Good. Yeah. Well, sure. I will be going to a concert in like an hour from now. So how long will it? For how long would you like to show me your project? This isn't working. Now I'm looking at the level editor, but unfortunately picking up tiles doesn't work for some reason. In the editor, you're supposed to be able to pick up all the tiles, not just once you just placed. click on the board. We click on that tile. Then we click on the tile that we have already selected. And there is a tile at that position. We pick up the tile. And you move the tile into the mouse cursor. I can join you on a call in a bit. Let me. I will look into this problem, into the problem here a little longer, but I'll probably give up soon. Okay, no problem. Wait, what? Perfect, look at that. There. The problem from earlier again. And a new problem. And the new problem is that we don't check whether we're actually trying to place the tile onto the board. already. We'll probably want to have a function for these two calls too, because it's the same between the duplicate button and just picking up tiles here. Okay, maybe not entirely. Perfect. It's working. Alrighty. Okay, bracket. I can go on a Discord call with you. Shall I keep live streaming? What is on? Hold on a second. Is there something weird with the level? No, it's not. Good. Hello.
Here's what the notation looks like, and now you're like, oh my god, it's one of these.
I'm not saying it yet.
So first of all, when you want to assign something, you don't use the equal
Oh.
sign. The equal
I mean,
is
it is one of those, but I like it immediately.
okay. Secondly, it doesn't have types, but you can kind of do them by doing something really funny that actually kind of makes it so unit tests become like kind of expected in the language. And that is you define a lambda that returns an object with properties that have like default values, but you want to make those default values like as random as possible by default. Okay. And then when you want to set something to be a specific type,
as random as possible.
yeah. Well, it's just because like that, whenever you want a unit test, you just toss in a bunch of those fucking classes and then just turn them into objects by like calling them, right?
Okay.
And so basically we can quote unquote assign types like this. They might then ask the question.
And it's a lambda with 0 parameters.
Exactly.
Okay, that makes sense. And it's actually basically like the init functions in Python, right?
I guess, yeah. And so you can assign things like this. Now, these are the 3 things that I think make the language pretty cool. The first one basically allows you to collect all of the variables stored in memory that are of a specific type or its subtypes. Now, because this language isn't like statically typed or anything, the way you determine subtypes is just by the names of the properties, right?
Mm-hmm.
So in this case, even though like B has like a property list and C has a property test property, right?
Mm-hmm.
Both are subtypes of A, right? So if here's the other thing. Like none of the operators use any words. I just did this because I wanted to piss someone off, right? Not because I thought it was useful. So this is how you print a screen. And you're like, why this? Well, because it looks like a little screen of a light on it, like you're printing.
Fair enough, I've seen worse.
And so if I look at things that are of type A, right, and I just call that, it'll actually like start saying, okay, first of all, I have to call it like that. So like that, we do that. There you go. A, B, C, D, E, F. Even though A and B are of type C and B, these are subtypes. And it determines it ad hoc, right?
Mm-hmm.
Which is pretty cool. I don't know any language that does anything like that. Now, this is useful because like that, you don't have to have like a major thing where you're storing like all the specific things, right? The other thing is like if you want 2 types to be different, like the language automatically makes you like think of it as, well, if they're different, then you have to give them different fucking things, right?
Wait a second. So subtype means you assigned the lambda to a variable?
A subtype is simply, okay, just first of all, think of a type as just a collection of words, as just a set of words, okay, that define its properties, okay? A subtype is just a superset in terms of those properties of that type, which basically means if I have a type that has the properties A, B, and C, named A, B, and C, then A, B, C, and D would be a subtype of that, just because it has A, B, and C in it. Like it could have like an E here, it doesn't matter, right? And then if I had like A, B, C,
you're talking about the values or like the possible values that a variable can take, right? Like you're saying a subtype is a subset or a superset of it?
It's technically a superset in terms of the property space, but it's like this is just how I'm defining it. The reason why this is useful is because this is inherently what you typically do when you're programming like an OOP. Like when you make a subtype, you want to give it something extra, right? The other thing is inherently, if you have 2 types that are like this, the language is immediately telling you like, okay, you're doing something kind of wrong. Like, why are you making 2 types that are basically the same thing, right?
There are a lot of reasons to do that, but for example, maybe you want, for example, session IDs and user IDs, and they're both integers, but you still want to make sure that you like don't mix them up. Like a function that will use the integer you give it to look up a session from an array should only be valid.
Sure, but then the question is, isn't that a bit overkill for like sessions and like IDs? Like, if you're, like, why are you going as far as to make a type just for what is in essence just an integer?
Yeah, exactly. That's exactly the reason why you want to do that, right? Like I think that's something you actually have a lot, right? Like very often you have a bunch of arrays, right? And each array stores like a bunch of different things at various indices, and oftentimes using the index for one array to look something up in the other array is not actually a useful like thing to do.
Well,
And
you could just make one user ID and call the other one like session ID. Right.
Exactly. Like if it
like by just changing the names, you can also just make that difference, right? It's just that it either becomes like confusing or unnecessary to just have two types that are basically indistinguishable from a property standpoint.
The one thing that any type system ever does is disallowing you from doing things that you can totally do. Which like that's the main purpose, right? Like, oh, you want to perform integer addition on a float type, the processor can do it. You probably don't want to.
The processor can do it, but can you? So this is one feature that I find kind of cool. You can just like call a bunch of things. You don't have to necessarily like this isn't a particularly efficient operator, but I think it's a really cool one.
That's fair. So one question about that though. So let's say you have a bigger program.
Okay.
Does every part, like, is every part aware of all the objects of every other part? Like, is there some kind of, I don't know.
Yes, it accesses everything globally.
Like
now, the way that it accesses everything globally. Now, technically, if I were a good programmer, the way I would have implemented it in the compiler is to make it so it makes two hash tables.
Yes.
One hash table basically stores like ad hoc a type and its subtypes, right? So basically, whenever I find a subtype, it just maps it to like one of the types, basically just an equivalence class kind of thing, right? Well, it's not necessarily an equivalence class, but you get the idea. It's basically to like look that up quickly, and then another table would be this one would actually be changed in real time, and that would be to like assign variables to their respective types.
So
and like
you're
that, you can do like an instant lookup.
That you didn't use a hash table.
Well, I'm using JavaScript's built-in one. I don't know if it's going to implement
that. It's a hash table. Perfect.
Like I wrote the transpiler in JavaScript, and you can actually see what the JavaScript code looks like here. Right? Because it translates it to JavaScript. Because I was like, well, that's particularly easy to do. Not particularly efficient JavaScript, but it's JavaScript that I know will work.
It looks surprisingly not so bad.
Yeah, and this is without formatting. If I give it some formatting, it's actually pretty readable, surprisingly enough, right?
Yep.
Another thing is, by default, all variables are global, and if you don't want to use it anymore, delete it. This has some upsides and some downsides. I think, okay, this isn't a feature that I wanted to mention earlier, but I think it's still kind of a funny feature, and that is whenever you're using a Lambda, the arguments are automatically named 1 through n ?
Okay.
If you want to access it,
like in Bash. There are some programming languages to do that.
Yeah. And if you want to access it like an array, I'm pretty sure you can just do like dot ? And then like put the index here, right? Since dot is just the operator to like access a property or something, right? Like here, you want to know how you get the maximum? You do this. Why? Because it looks like the supreme symbol. And this looks like the infimum symbol.
Okay.
But anyway, so that's just one of the things. I still think the printing thing is such a dumb thing. I used to have it as print, but I was like, I want to make everything a dumbass symbol so I can like give others a good laugh, right?
Yep. You know what it's really lacking? It needs more emoji.
You're right. I'll start like implementing Unicode things here. The next thing is cool, and this is probably like cool and actually useful in like a couple significant senses, is the filters in this language, right? So to filter something, first of all, you are going to specify the sets and their respective properties, which I'll explain in a bit, and then you'll put a function or a lambda there, right, at the end.
Makes sense.
The thing is, the way
I
that this
just
works,
only now realized, so dot slash looks a little bit like a
like
lambda.
a lambda. That's the point, yeah.
Okay.
Like I would love to just actually make a lambda symbol. I don't want to be a fucking masochist and like
You can-
copy it
you
from the
can totally
Unicode
do
website
that.
each time, or make a macro on my keyboard for it.
Just remember the Unicode number, then you can like hold Alt and type in the
Yeah,
number.
I know,
on
I
the-
know. Like I already do that for like I already do that for the M dash when I write. But anyway, the thing is, you don't just quantify over like a particular set. No, that's too easy. You can use first order logic here to like put in like a bunch of sets and then like make a quantified question. Like false just means there exists, and then true means for all. So I can do something like this. And it's like there exists an element of the first list such that for all
Hold
elements
on
of the
a
second
second.
list.
Why exactly does false mean for all? Why
No,
is
false is there exists and true is for all. This just means is it a universal quantifier?
so? And did you are false and true are those things that that you have defined in this file, or why are they
Yes.
not? Okay.
Well, well, no. The
If-
false
if
and
they
true,
were-
they're
if
just
they're predefined, then why do they use letters?
that's just how the language works. It's like when you like, for example, in JavaScript or like
Yeah, I
like
know,
literally
but
any language,
surely
you
you
can
could
just
have.
write true.
Surely
right?
you could have used some like symbols for it, right? Like maybe plus and
Oh
minus.
no, the operators, those are always symbols. True and false though, those are.
So are you saying true and false are not just operators with no parameters?
No, because then otherwise I'd have to do it like this. Otherwise, this would just be
Yeah.
a memory address that says where the function is, sort of.
Yeah. Alrighty.
Anyway, anyway, so you can ask quantified questions such as there exists something of like, I mean, we'll just call this A, such that for all elements of B, then you can even go further, like there exists an element of C, and then all of these will be tossed into the lambda as an ordered list. So you can like access the first one like this, the second one like this, and the third one like that, right? Or using the array notation that I specified earlier.
Okay, so
And then
the
it will
result,
return
the result
and then it
is not the return value, but
the
you pass in a
results-
lambda that gets the result.
This
And
lambda is just
return-
like this lambda is just the predicate, like the thing that's going to be evaluated to determine whether or not we should consider that tuple.
So that lambda is being evaluated as either true or false, or
Yes.
okay, okay. And so what is it doing right now? It's just 1, 2, 3.
Yeah, this,
Like, what's
this
the
is
truth?
actual. This is just like nonsense. Like, but like in theory, I could say like, if the sum is like less than 10, I don't fucking know. Like, sure, we could do something like that. It's not particularly useful or interesting, but we could do something like that, right? And the return value of this is a list of lists where each list in the list contains basically what value satisfied it. So maybe like it have like 1, 2, 3, right? 901, or actually it have to be 900, right? Because it has to be strictly less than 10, etc. Right? Where like the first element belongs to A, so this is an element of A. Second element belongs to B, and the third element belongs to C. Like,
I
don't
find
know
it I find it very funny that you also have like the braces, curly braces as an operator.
Mhm,
So like the only kinds of braces there are the round braces
mhm.
and the curly brace operator.
Yeah.
Because you could have just said if instead of round
Yeah,
braces
you
you
use
use
curly
curly braces, it's the same as I guess round braces with the curly
But see,
brace
that's
operator.
inconsistent notation, right? We're not having that in this house.
Yep.
Like in theory, I could have just made it so binary operators work like this,
Indeed.
but I hate that. Anyway, so this is, I think, something that's really cool. Like I don't know of any language that natively implements first order logic into filters. Like I know you can like get
Prolog?
around by like doing.
Prolog?
See, it has first order logic, but it's for like its proof system. So this is like something that's actually like computed.
Prolog?
I think you can do it in Prolog,
Okay,
but
cool.
like, no, I know Prolog has first order logic like that. That I know for sure.
Mhm.
As it's like proof system. That's kind of like the point of it. right? But like I said, I don't think it has a filter operator.
I guess you could say it has nothing but.
It has nothing but first order logic. Like what I'm saying is we have a first order logic operator built into the filter. Like that's what's cool to me, because filters are extremely useful, and first order logic is extremely useful. But I don't know if any language has both of them in the same thing. Because in theory, that's basically what you want to do, right? As for how this is implemented, instead of doing the Cartesian product of all these sets, there's some like clever math to like just make it in like one go, and you like iterate over moduli and whatnot.
Oh, well, I guess in SQL you can do that, right?
I mean, yeah, but like I don't know if I'd call SQL a programming language instead of a query language.
Yeah, it's not a programming language, but
like technically any programming language can do this. Like this is literally the code of JavaScript to do it. It's just a pain in the ass to do it in other languages, whereas here it's like one of the main selling points.
No, I'd argue that your language isn't a programming language either, right? Because you don't specify the steps to be taken, but what you're specifying what the result's supposed to look like, right?
I mean, you can say here like this equals that kind of thing, and then here are if statements, which look like this like symbol from like logic, by the way. Then here's like the condition. Here's what happens if true. Here's what happens if false. This is just like make it so you can like have a code block kind of thing. So you can do this and do that, etc. So yeah, it has basically everything you'd want. Mm-hmm. You can even print to screen, as you can see, right? Like right now, the way that it's implemented is it's just JavaScript, but not, right? But the cool thing is that it implements like tons of things that I wish other languages had. Like I said, this first order filter thing. Do you know how many fucking hours that would have saved me over my years of coding? Like think about like, okay, you want to find like a specific bullet that like does a specific thing. Like whenever you're thinking about like writing abilities in games, you're always thinking about it in first order logic, basically. Like, oh, is there like a tile such that all tiles around it like are of a specific color kind of thing? It's like, okay, well, first of all, iterate over both tiles, and if you want to make it more efficient, then like find a specific tile that you want to analyze and like make it into a graph, and then just find its adjacent nodes, right? Which would require you to change the structure fundamentally, but also it's a more efficient structure if that's what you plan to do. So it's also just inherently telling you like, if you want to do this, redo the structure. But even if you like, let's say you don't want to redo the structure, well then naively just iterate over the set of nodes like twice, right? And pass in a function or lambda that basically evaluates whether or not like that's true, right? There exists a node such that this is true, blah, 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 return it, right? And I think that's really cool. The other funny thing of the language, there are a lot of funny things in this language. Oh yeah. There's this operator that turns any string into a reference in memory to the variable that has that name. So like, for example, if I put here A, this is just going to return A.
See,
again,
that's also something you can do in Bash and in CMake and in Make. For like my great confusion when trying to read any of it. Like,
yeah.
So because if you can do that, right, you can also do things like do a bunch of string concatenations that turn into a variable name and then access that. You could do like, so you could have a hash function, right? You could be like, okay, hash this string and then interpret the hash as a variable name.
Like, yeah, you can do tons of things. I think it's kind of okay. It turns out to be very useful because then you can just sort of interoperably like just like play with variables as if they're like just strings, but also just play with them as they're actual things with content. Which sometimes can be more efficient because sometimes, like, let's say each of these is like a huge ass object. You don't want to be like carrying all these around. But it might be more useful to have them named than just be like, oh yeah, that is like collection of objects index 0, right?
Why can't you have something like a map? Like key value pairs?
Well, yeah, no, you can do that too in this language, but you don't have to. Because it's all just works like this by default. Like that's literally how this part works up here, right?
Mhm, I thought so.
Like an object is, in essence, just like a map between the properties and its values, right?
So what is question mark minus 0.5?
Oh, the question mark operator? That's how you make a random number. Why? Because I'm tired of every fucking language doing math.random. I don't want to type math.random. That's like the most annoying shit ever. So this just returns a value between 0 and 1. You
should use C++. The other function is just called rand.
Wow. Here's even less letters. One less letter.
So this is a number between 0 and 1?
Yes.
Which
is why I'm like subtracting this and then multiplying this, which is between negative 1,000 and 1,000. Yeah.
All right.
Yeah. Also, the way that this works is first there's a property name and then the value, and so on and so forth.
And they're not grouped together. It's just.
Yeah, it's just they're in a list. Why? Because grouping them together would be like, okay, well, what would that look like? Well, first of all, it has to be like a list or something, and then we have to put it like that. And that just sounds like, why would I want to write the notation like this? This just actually sounds annoying. And if you do have it stored like this and you want to do it like that, then unwrap it. We have an unwrapping operator. And so just map over and unwrap it kind of thing. And yeah, this is what I'm... So basically, I have this like website where I have like a D&D campaign, right? And so we were originally using another website, but see, none of the abilities there are automated. It's all like I have to calculate it manually, and I'm like, I don't want to do that. I'm a programmer, right? I hate doing stuff manually. That's that's the name of my job. So I started like coding an entire website where I could run that. So the website works. You can move around tokens. There's a whole chat implemented. You can role play certain characters. When you click on a token, it'll like bring up their abilities and whatnot. Not that any of them do anything right now, but that's because we're simply changing the system. Like before, there were some abilities that worked. It just we're changing how the system works. That's a design problem, not a programming problem. So I had a previous programming language for that, but I realized that defining like functions that you could then call under like really specific circumstances was a pain in the ass, because originally that was just meant to be a query language that I slowly changed into a programming language. But because of that, like it inherited a lot of the problems of like query languages. And I kind of just like said, whatever for a while. But then like I was like, fuck, I kind of want to change this. And then I was like, it probably isn't that bad. I mean, yeah, the transpiler is like 100 and something lines of code. It's not that bad, right? It's a pretty lean transpiler. Because most of it is just like there's a map between these things. Yeah.
Indeed. Interesting. And you're just building JavaScript strings.
Yeah, and then it just evaluates them in JavaScript. Yeah, like that is indeed what happens at the end here. You just eval the JavaScript. It even says JavaScript is just compile code. I would love to make this into like an assembly thing, but I feel like that's more trouble than it's worth. Like it'd be a fun like experiment and learning experience, but I also don't know if this is like the language I want, right? Like because a lot of like what I'll like or hate about a language comes down to what I'll end up learning from using it. Like the other language I thought was great, and it had things that this language doesn't have. Like to define a relation, you wouldn't even like do anything like this. No, you would just like put a bunch of things in a list. And this would be basically treated as like a piecewise function, where like A is kind of a function, but it's not defined as like a lambda or anything. It's just like a piece of, this would just become a string that you can then access. And that string could be given a value like false or true or 10.
Like an atom in Prolog. Not an atom,
exactly.
A predicate. Or would it be an atom?
Well, an atom would probably be something like this. This might just end up being it, but it doesn't matter. Yep. Point is, this language can't do that in that notation, but the notation for doing stuff like that also isn't that much worse. It just depends on like they're just 3 notations. Basically, like if it's something like this, you probably just want to end up like defining a property of a type and then like just calling that property on A and then defining it as 10. For the record, the previous programming languages like notation for that wasn't this. It was this, right?
AB
So
turns
it's
to
not.
C.
So it's not that much worse. In particular, I think. Sorry, no. Typically, you define it as this because you'd want to like have something called B, right? That you can then call on A. In particular, this would be a variable A. You just want its name, so you do something like that. So it's kind of the same. Some things are different though, right? Now for like 3-pair operators, it's the kind of thing where, again, you want like almost the last one always, right? So you just like CAB. Yeah, like you can do that all in this language. Just the notation is a tiny bit longer and slightly different. As for what's going on here, currently I'm coding like I mean, it's not going to show anything, but basically I have a turn order here, right? And I want to do a couple things. First of all, if someone's dead, right, which is in this case right here, and like health is less than or equal to 0, right? Then I want to basically remove them from the turn order, but like keep things in place because I can't just naively remove them because then like it might like skip someone's turn, right? So I first like do a couple checks and then I remove them. It's not like realistically I just need to check like whether or not the turn index in the array is less than or greater than rather the person who's dead, the index of the person who's dead. And then if it is, then subtract 1. And yeah, otherwise just don't do anything. And here this just like
hold on a
keeps,
second.
Like,
-1 question mark? Does it mean?
No, this is just like we're subtracting r from this argument.
Okay, what does the question mark do here?
That question mark just means because here's a lambda.
Oh,
just like the first
I see.
argument of
So
lambda.
this is the
So the way
parameter.
this is working, this is like a for loop, right? But what I'm doing is I'm mapping over 0 to the index of turn order.
I see.
And so yeah, this is just saying like, okay, get this turn, but the reason why this is the case is because like when you remove like since we're like iterating over from 0 to n, right? Like this is evaluated first. So even though turn order's cardinality is changing here, that's not going to be reflected over here, right? And so you want to remove whenever you remove an item from turn order, you want to like go down 1 basically. There are other ways of doing this. This is just the way I did it, and since like I don't want to use r after this, I delete r. Like one thing that's kind of fun is console.logging this. So then when I do that, it shows you actually just the final state of the program. So as you can see, we have this, A, B, and C are like the types, which are now anonymous functions. Note that now turn order, we removed a couple of them, right? It's A, B, C, D, then E is gone, right? And the reason why is because E had negative health, right? Note that again, because of how like the type things are defined, right? And like naturally, I just want people to use it randomly. This allows you to like basically unit test your code, right? Just by compiling it. Because it's going to give them like fucking random values, and then it's going to like produce the code automatically.
Well, okay. I mean, yeah, but like in unit testing, you would also want to set the parameters to specific edge cases, right? So like I don't know, maybe you have a. For example,
you can do that over
one
here.
thing this doesn't tell you is whether the turn index thing works when the health of one player is exactly 0, right? You could have an off by 1.
You can do that. I don't have it here, but there's a function that I have implemented in the other one, which I'm eventually going to bring here, just called choose. So like I can make a list of here's like a random like fucking value between this. And then like let's say I want it to be like exactly 0 or whatever. I can just do that. Maybe exactly 1. Right, and then I push this through the choose function. Like, what do we call this? But yeah,
it's all nice, right? But like, how do you iterate over all the examples that you give? and maybe all the combinations of these examples. Maybe just select one randomly, and what you can do is you can run your program a million times and hope that all the important cases came up.
Yeah, I mean, there are a couple of things you can do for that. First of all, if you want, you can technically give this operators, right? And then you can define, and then like we can make it so based on the operator, it's a different edge case, and then you just push in like, oh, this is type 1, it's type 0, type, because we have that many edge cases, Granted, if you have that many edge cases, I'm pretty sure your program is just edge cases. So you can do something like that, right? There's nothing stopping you from doing that. And if you want to like iterate over all possibilities, like you can technically just use the filter, set the predicate to true, and then it technically just produces the Cartesian product, right? When you like put in like a bunch of lists and shit. So that's the way of doing it, which I don't think is that bad. I mean, it's what, a couple extra characters here for each edge case in the sort of thing. Then you just put in like which type you wouldn't even do anything here. You likely wouldn't even do this. You just do this and then put this like iterate over turn order, right? So it'd probably be like, okay, we want to map over. Let's say that this is like the set of exceptions over here. I'll just call it E or something. All right. These are like the edge cases we want to look at, right? And I'm just gonna make it so the lambda returns true. And then in here, what I would do is so I'm gonna have a code block here. Actually, I probably want to iterate over turn order first, and then iterate over this for each one in the turn order. Okay, so just iterate over turn order, and for each one in here, we're going to generate this many exceptions. Since now we just need to do this here. I can do this. So what I'm going to do is here is I'm going to map again over this set. And here is where I'll have the code block. So yeah, and here I could then say like, oh, define this as being that, and so on and so forth, right? Based on just the stuff from here. So yeah, like I don't think it'd be that bad. Like, just have to write a bit for like all the combinations, but
Can you do things like theorem proving? For example, can you do something like show me all the
all the ways my life is wrong.
Yeah, that too. But can you tell it to show you all the parameterization of a lambda that causes a specific thing, for example? Because that would be very difficult.
I mean, okay, first of all, there is no theorem proving at all like by default. Now, if your question is how hard would it be to implement
like, the thing is, but what I'm thinking is if you have a way to say, okay, like give me the values for which a predicate is true for all values in some variable, right? So for example,
I mean, that's just called the filter thing, isn't it? I mean, assuming the domain is finite.
So the filter can only iterate over a concrete set, right? It can't be I
mean, sure.
An indefinite set that has some kind of
but if
definition
you want to, like,
of how
if you want to like consider like thousands of random values, you could in theory do that, right? Most students. So here's the thing about theorem proving. It's very cool, but I also sometimes I also think to myself like, what am I like? How much am I going to get from implementing it in this, right? Like, let's say I spend like a month and I have the coolest theorem prover on, right? It's like realistically, without like using some sort of modern like search technique from like neural networks or with neural networks or whatever, I have no idea how far it would go to the point where it'd be interesting. Because what you'd want a theorem prover to do is prove the things that aren't trivial, right? The thing is, if you're just combinatorially looking for things, it's only going to prove the trivial things before the end of the fucking universe, right? So you need like some sort of search space optimization and a bunch of heuristic thingies, which either A means you have tons of people that are willing to like write in all those extra little things that it should search first, or B, you're going to implement some sort of machine learning technique or some statistical technique that looks at the things that happen to be interesting first, right? The problem with the neural network approach is I have no fucking data for this because I just wrote this fucking programming language, right? Now, in theory, I could probably figure out a way of getting data from other languages, but as you can see, no matter what path I take, this is a lot of work, right? For realistically, something that I personally think would be really cool, but I don't know how much I would be able to gain. Now, it is possible that I could make like restricted theorem provers, like, okay, prove things for like these operators only over the set of integers, or only over the set of reals, kind of thing, right? Like I could possibly do something like that. It'd be a lot more restricted than like a full theorem prover, but I could see myself like that seems like something that would take a week, not years, you know.
Maybe a few weeks.
No, I mean I programmed the whole theorem prover in a week once. And then you just have to program the axioms of like the reals, which isn't particularly efficient, but I said I'd do it in a week, right? As for like an efficient one, like the first thing that I would do is create another like parser, and this would be done at compile time for the record, right? Like maybe I could do it so that it would work at in real time. I mean, there's nothing technically stopping me, but at that point, I might want to store functions as like their like string definition versus like a memory address, right? And then like have some sort of weird thing that like weird symbol at the beginning that says, yeah, this is definitely a function. So quickly, like in real time, convert this into like a JavaScript function when it's parameterized with 0 parameters. Like if you're like calling it successively, like in like Haskell or whatever, right? So with that, I could probably do it in real time. But let's just say we're only interested in compile time proofs, and the programmer would be diligent enough to write all of the functions there instead of making a function that generates functions while the code's running, right? Like in theory, if you're only going to use that many functions, you don't need the code to generate like functions as it's running, right? So, sure. Let's say we go with something like that. Let's say then that we can easily, like in theory, it's easy to check if like a function is only using like the standard operators, addition, multiplication, exponentiation, and so on and so forth, right? And let's say that we're only interested in those that do that, right? Let's say we have a way of checking as well if the function's only going to be used for like numbers, or maybe we could just like have a flag, like a compile time flag that isn't actually used for the code. It's just a compile time flag. It says, hey, make a proof over this over like the real numbers. And so the programmer is inherently saying, I promise that this will only do this. Will they actually only do that? I don't fucking care, right? I'm just the person who writes the compiler, not their babysitter, right?
I think they're pretty close though.
Yeah.
Compilers and babysitters.
Yeah. So assuming all of those things, what you would have to do is make it into a sort of mathematical expression, which again isn't that hard. I already have an AST parser kind of thing. I just would replace it with like a math thing instead of JavaScript. And then I would have either a bunch of interesting properties proven, or a couple other things. Because the other thing is, a lot of the time, exceptions don't come out of, oh, I didn't test like this really specific, like, exceptions don't come out of, I didn't test this case I knew. They come out of, I'm going to test this case that I didn't think about, right? And so realistically, what do I want? A theorem prover that like proves things that I want it to prove, or a theorem prover? Because like here's the thing: if you wanted to prove something if you want the theorem prover to prove something that you want, you're gonna just say prove that the program works, which is too
Yeah.
complicated for us, right?
Well, yes, right, but like proving that certain conditions never happen is already pretty
Like
useful.
that's already good, but like it's also like one of those things where you're probably going to do that manually, right? Like if it's a very specific case, you're probably going to do it manually.
Well, I'm thinking the only reason we're doing it manually right now is because there aren't any theorem provers that we can use
Well, when
in
I say
programming languages that we
like,
actually
a lot of the
use.
time, it just takes like 3 seconds to like think about it, right?
What do you mean?
Like so we can make mistakes, of course, right? But like in most cases, it's just that. Like for me, bugs, like 90% of bugs don't come out of that, right? I see like maybe 1% of bugs come out of that, and usually those are the kinds of things where like, wait, shit, let me double check that condition, and then you think about it more if it actually is a bug, right?
So what you're saying, what kind of bugs do you make?
The kinds of bugs that typically appear are those that you're not considering. So
Well, yeah, but a theorem prover can look for things that you hadn't considered.
yeah, but that's only if you're saying, hey, does the whole program work? Because like typically those kinds of bugs appear from interactions between things, not a thing in and of itself.
Exactly.
And
It's
so my
always
point is-
interactions.
So for me, what's more interesting isn't a theorem prover, but an exception finder.
Well, yeah, I mean that's a thing that a theorem prover can do.
But the emphasis is on like two very different kinds of things. Like the idea of a theorem prover is you give it like a hypothesis, you give it a thesis, and you ask if it's true. Whereas an exception finder is you give it the program, and it will somehow find inputs that will fuck it up.
The hypothesis is this program does not crash, for example.
Yeah, I know, that's what I said. But
And then the theorem prover will be like, well, actually, if you press this button and then this button very quickly.
well, no, the theorem prover would just say false. And then you'd have to like have some sort of snack trace or something to figure out why it's false.
A good theorem prover also tells you, like, in which condition or like with which parameterization the.
No, like I said, they are functionally equivalent, but like a theorem prover that takes in a whole fucking program, like a big program from start to finish, is not going to be able to prove anything interesting by the time like the computer still works, right?
That's the real problem.
So what I'm saying is, what would instead be useful is something that can just find areas at which an exception is likely.
Yeah, indeed. So one thing I would really like to see is a program that I can give like a number, like an amount of time maybe, or like a number of steps, right? Like for example, look for any crashes in this program that you can find within 10 million iterations or steps or whatever. And then you can be like, well, it doesn't crash within this many steps, so maybe it's all right.
Though you have to ask the question of like, does this take in user input, and how complicated is the user input? Because
exactly. You would have to consider every representable user input.
Yeah, sure. And maybe the way to do that would be to somehow categorize, like partition, like certain areas. Let's say, like for me, like I've thought of that before, but the immediate useful case, and it's a very useful and common case, that just seems to break down in is okay, what if they're on a 2D plane over the real numbers? Like what? Are we going to test every fucking real number now, or pair of real numbers?
So luckily our computers are discrete, so you can actually iterate over every possible.
But do you want to iterate over like the product of all possible?
Yeah, you have to be smart about it.
No, which is why I said you want to partition it.
To be fair,
every single float isn't useful, but every sort of jump.
To be fair, our computers, our processors are actually really fast. So you can actually totally write a for loop that iterates over every possible float, and have some simple condition checked for each possible.
Well, here's the thing: the condition check is your program works, which takes in your program.
And it's not just one float, right? But
but two of them.
And
that's if it's
actually,
a 2D game.
If it's 2D and if you only consider one frame.
Yeah.
there's
And
actually
remember,
millions
you
of
want,
fields.
yeah, no, you want to do that for each time. You want to consider, or like actually, it doesn't matter which one because you're just trying to do a for all,
Yeah.
right? So you can
Yep.
switch the order around. You can even look at one pixel, then look at the time, then look at the other. Well, okay, when I say pixel, I mean like x or y coordinate, right? Doesn't matter. Point is, you want to iterate over all of those. And 10 milliseconds. Okay, well, what's your it's not 10 milliseconds. Like let's say 10 seconds. So what's the frame rate of your game, right? Or the simulation time of your game, right? Anyway, point is,
It only works if also your game can be like really fast to evaluate.
so I think that a cool kind of thing. This is something I've thought about before. Is basically there is branching code everywhere.
Mhm.
So what if there were a thing that basically like made it explicit? Like when I do when I call an index of an array, right? There is like branching code there. Like what if it's out of bounds, right?
Yep.
And basically, what if it automatically generated like a decision tree from my code with all of the branches, right?
Yep.
Because and we use that decision tree to partition the space of possibilities, right? See, that is always discrete now because our code is discrete. Or sorry, not only is it discrete, it's finite because our code is finite, right? There are only finitely many decisions a program has to take. Otherwise, it's not a program.
Well, yeah, but the depth could be infinitely large if you have loops.
Well, we're assuming our programs halt.
Okay.
Like,
Yeah,
otherwise, I don't know what kind of program you're making.
Of course, right? Like, of course, let's assume the program halts, but then the depth could still be very big.
Well, yeah, it could be very big, right? But depending on how you structure your program, it doesn't have to be. Because again, if you can avoid using a loop, avoid using a loop, right? So it just comes down to, like, because again, if your program is as simple as it can be and it's still complicated, well, there's not much we can do about it, right? So yeah, and the thing is, we're not actually interested in like proving syntactically that like, hey, look, there are going to be this many branches over here. All that we care about is that there's at least one branch. So the mere fact that there is an if inside of a for loop, we don't need to see how many would be there, just that there is an if there, right? And basically, this serves as almost an attention mechanism. Where should we focus our attention on? Again, things that aren't branching, their behavior is obvious because it's literally just one possibility, right? And so you can, in theory, test all of those with just one test.
By the way, that's actually something that is being done, right? So like the C++ compilers, for example, can like output lists of all the points in your code where there's branching, and also output how often each of the branches are being taken, and that's used to do coverage testing, right? Like you would write some unit tests and then you'd write the compiler, okay, if you run all of these unit tests, which code paths are never taken? And then you can look at those and maybe write a unit test to also look at that code path.
What I'm saying is a bit more extreme. I'm saying don't even bother with unit tests. Like this is a partition of the entire space of possibilities, right?
Possible paths through the code.
And so take every possible path, right? Note that because it is that, you can also do some things like automatically say, I'm not interested in this, because like let's say you just trust that code, right?
Yeah, it's
like you can test it later,
maybe,
right?
or
like
something.
some library code that like it's been used in the industry for years. All the major problems have been resolved, etc. Right? Maybe there have even been theorem provers looking at it, right? Doesn't matter. Point is, maybe you only care about a specific part of subset of the branches. Let me look at those and perform tests over those. Right?
Yeah. But so one thing, however, that we're ignoring here is indirect jumps.
Such as?
Yeah. What if you have a lambda? Like you have a function that takes a lambda as a parameter, right? and then you
Mhm.
call that lambda in that function. Where does it jump to? Well, it jumps to one of all the lambdas that could exist, I guess.
I mean, sure. Though there are some clever ways of doing that. Like, so lambda is just a shorthand for we're making a function somewhere, and then we're using it here. So if we like have a stack of functions that are the lambdas like stored to somewhere else in the compiler, and that we enforce lambdas at runtime,
Mm-hmm.
or sorry, at compile time,
Mm-hmm.
then in theory it's just one of those. We're just changing the name from
Indeed.
lambda to function hashtag and then ID or something.
That is true. That is true. There's another problem. What if you have something like eval?
Mm-hmm. So again, what I'm like the first assumption I made here is all the things that we're doing are things that can be evaluated at compile time.
Indeed. So
Like if
personally,
input could be anything, then you're basically saying, well, the program could be anything, and we can't see anything of it. And then at that point, it's like, well, I don't know what I can do, right?
Indeed. So that's why I try to avoid lambdas and like virtual function calls as much as possible, and also try to avoid having an interpreter or a compiler as part of my program, right? Because at that point it just gets extremely difficult to reason about what it's actually doing.
Oh, I take a step further. I have a compiler inside my server code, right? That
That
the
runs
client
an
side interacts
interpreter.
with. Yeah, that runs an interpreter that changes the main program. Like I have a variable called state, right? In the main server code, which is meant to store like the state of like the games and so on and so forth, right? And like the chat stuff. And then I call an interpreter. So I'm not even an interpreter. I call a compiler to turn my code into JavaScript, and then I eval that, and it changes the main program. So you might have the question, why don't you just write everything in JavaScript? And the reason why is because it's way shorter to do it here.
Indeed. Yeah, so I'm pretty sure that theorem provers can be very useful, but none of the programs you're writing, the theorem prover would have any chance on.
Of dealing with, that's my point. Like it's not that I like as a mathematician, I love the idea of a cool theorem prover. Just as a realist, I know that's not here. Right?
like the best the theorem prover could do with your programs is say, well, it's Turing complete. Here's the halting problem. Good luck.
Like it's basically the same thing as, okay, what can your theorem prover say about eval and then a call to like a specific file in your computer?
Yep.
Like I guess that is a program that it's like evaluating because the computer has finite memory. Like,
yep. So yeah, like I'm saying, like the best thing is it can reduce your question to the halting problem, and that one we can't solve. So it immediately proves that it's not provable.
Yeah. And so it's like I'm not interested in that. I'm interested in, okay, where could I be missing something, right? That, as far as I know, only really happens at branches. Right?
Bracket.
What?
I have to get ready for the concert now.
Yeah. Okay. But is Sandy just permanently there, or is she just visiting?
No. So my sister's boyfriend's band will play, but I will not.
No. I mean, because Sandy's there, right?
Sajini. Yes, Sajini will come with me.
Yeah, I know. So I'm asking, is she permanently living with you, or is she visiting?
I completely misheard you. I'm sorry. So right now she's here on a tourist visa. It will run out in December.
Okay.
And we're trying to get a residence title, but there's an uncountable number. Like there's.
Do you want me to give you a suggestion? This is gonna sound really funny. Have her get residency in Portugal, which is particularly easy, and then use that to transfer to another place in Europe.
We were thinking about something like that.
Yeah, because like a lot of people come to Portugal because it's apparently very easy to get a Portuguese nationality.
Oh.
They look into it. I don't know. I've just heard this a lot, and like it's funny.
So the experience thus far is that there are a lot of hoops, and every time you jump through one, two more appear in front of you.
It's like a decision tree in exponential growth.
Yeah, like just a few days ago, right? So the town hall was like, so a few weeks ago when we wanted to apply for the residence style, the town hall was like, well, yeah, okay. Thank you for that stack of documents. You're still missing this document though. We were like, okay, we get it. A few days ago, we sent them the document that we have
And
to
then
get,
they're like,
right?
but you need this one too, which you can only get from this guy, and this guy is not available till this day, so. And you have to pay like $100.
Yo,
for
I've
it.
done this before.
Yeah.
I've done this before.
Me? No, but I know how bureaucracy works.
Yeah, it's lots of fun. Alrighty, thank you for the call. I will end it now.
All right, bye. Have fun
Have
at the
fun.
concert.
Thank you.
All right, bye.